Hello, we're the impeccable inspectors from North Carolina A&T University. First off, we're going to start with our team introduction. My name is Shane Andrews. I'm the facilitator for this group. I clarify the aims of the group and help the group out to set sub-goals at the beginning of each meeting.
My name is Michaela Brinson. I'm the researcher, and I serve as a quality control person who double checks every detail to make sure errors haven't been made and search for aspects of the work that need more attention.
My name is Lauren Stewart. I'm the recorder. I take notes during meetings to keep a record of what has been decided, tasks that have been assigned, and when meetings are scheduled.
My name is Ashley Taylor. I'm the project manager. I create the project budget, take care of planning and systems development.
My name is Kanaya Watson. I'm the creative designer, and I'm in charge of designing the health checkpoints and responsible for creating the drawings and the blueprints.
From the beginning, our mission has been to keep citizens safe. With the recent outbreak of COVID-19, friends and family have found it increasingly difficult to stay safe and healthy. With the help of numerous team members, it is our duty to protect the students of North Carolina A&T and promote better cleanliness to make being healthy easier, faster, and more enjoyable. The outbreak of COVID-19 earlier this year has become a very big issue, and there's a great need to stop the spread of the virus. People all over the country are constantly seeing their loved ones become very sick, and even some are tragically dying. We need to take measures that will help protect the students at North Carolina A&T University. It is necessary that a system is developed to help keep track of who has the virus and who has possibly been in contact with the virus. With this information, we are then able to take proper measures to slow and eventually stop the spread of COVID-19. In efforts to abandon face-to-face interaction health checks to abide by the social distancing regulations, North Carolina A&T State University needs user-friendly health checkpoint stations that have no human face-to-face contact.
The name of our device is called Aggie Aid, and the purpose of Aggie Aid is to take students' temperature and with body temp sensors with no human contact. This device will be used to track students' temperatures by scanning their Aggie 1 cards and entering responses about COVID-19 symptoms. The responses will be collected by the device and sent to the health center so that data and information on each student are recorded each time they use the device. Like any other in many hospitals, employees are often standing outside of entrances taking people's temperatures before entering and asking a variety of questions regarding COVID-19. To eliminate the close interaction with people, Aggie Aid could easily take the temperature of students with no contact at all and take responses with the screen once the Aggie 1 card has been scanned.
So basically what they're being screened for is their temperature. Temperature screening has been the most accurate, although not perfectly accurate, way of determining someone's chances of getting COVID-19. So far, temperatures have been done using radar scanners from humans. People will normally drive through drive-throughs and then are able to get their temperature scanned as soon as they show some identification. What we're doing is using a robot to eliminate the human contact perspective, as well as also administering a temperature scan. They're being scanned through our facial recognition software. And what the software is capable of doing is taking someone's face, using the radar sensor to scan their forehead, and then taking that person's face and then like putting in software saying this person is now clear of their temperature and is now safe to enter the building. This is also able to be done with a mask on, so people are still maintaining safety while they're getting scanned.
For our Aggie Aid device, we have 3 different prototypes. For the first prototype, this one has a built-in hand sanitizer dispenser for people to use as check-in when they enter the building. For the second prototype, this one has 3 screens so that multiple people can use the Aggie Aid at once. And for the third prototype, this one has a mobility feature, which is good for busy and/or crowded areas.
This is our decision matrix. We considered all the criteria for each prototype with this and was able to come up with the prototype that we would use. Putting in a mobile device in every entrance would require a lot of devices and will disrupt the flow of busy areas like the Student Center. Through several analysis in our design matrix, we decided on Prototype 3. Prototype 3 has mobility abilities that would allow the device to move safely on smooth surfaces. Mobility is a great attribute, but there are still concerns. The device will have limited capacities when crowds are too large. This should be fine if students follow the university's capacity guidelines.
This is our final 3D print for our prototype design. You can see the 4 main parts: our tank treads for mobility, the hand sanitizer dispenser that is no contact, the facial recognition panel, and then our solid steel adjustable measuring device for people's heights. All these components make our Aggie Access device as a capable mobility, scanning recognition, hand sanitizer dispenser, and adjusting for people's heights to scan their faces.
The capabilities of the Aggie Aid are temperature verification to see if your temperature is at risk for COVID or not. We have facial recognition and mask detection so that you don't have to put your mask down. There is an alarm threshold temperature calibration and it is Wi-Fi enabled. Some features are that it's hands-free. All you need to do is scan your Aggie One. It's touchless and it will give you voice prompts on what to do next. It has a fast 1-second detection with an auto alert. The temperature accuracy is very precise. There's an industrial grade infrared camera for when it needs to scan your face. There's an easy plug and play for temperature screening, and it is an LAN or Wi-Fi connectivity.
So this is our pricing of our device. So basically, it includes LED screening, CPU, speakers, card ID, scanners, silver pedestal, and tank treads. Those come to about $3,000 and $3,000-ish. And the university has budgets for way higher devices than this, and especially because COVID-19 is such a massive pandemic and it's only getting worse. The university is going to really want this. And because of our mobility aspect, we're able to only buy maybe 5 or 6 of these devices. So instead of putting a health check for every single entrance in every single building, you could put a couple in some buildings and the device will be able to move around, scan people's faces, and it'll also limit the total budget for it. So it may be more expensive than your average non-mobile device, but it's definitely worth the price if you take into account how many you have to buy. In conclusion, Aggie device takes students' temperatures by temp sensors with no human contact. And so everyone in this project had to create a device with no human contact, and we made sure that was accomplished and then some. With the mobility aspect, like I said earlier, it's able to go through any high dense population and walk around and scan people's temperatures. Students are also more likely to interact with the robot because of the mobility aspect. We found that places like malls and like China already have like robots that go around and greet people around the mall. And so students are more likely to be interested in something that moves and it's a cool robot like this. Also, with the mobility aspect, there's no lines for people getting scanned, and lines are kind of counterproductive for people in this COVID-19 era. And so in addition, this device can also be maintenance by people who are in like computer engineering, electrical engineering, mechanical engineering, and they can kind of maintain this type of device in their classes and gain experience when working with robots. So it also has an educational aspect as well. Thank you for listening to our project.